Hello, my name is Shelby Howerton, and this is my Lab 1 amount of excess charge on an ordinary object. The basic introduction is that we are creating charged particles from neutral objects, and we're determining the interactions between the charged particles and finding the axis or absence of electrons from these charged particles, and then stimulating our findings on the VPython, which is GlowScript. And then we're going to look inside to our findings and see that the charge shape was net positive, and that charge was 2.57 times 10 to the negative 8th coulombs, and then the number of electrons in the tape was found to be 1.60 times 10 to the 11th electrons. For my lab materials, I used clear tape, a ruler, a flat surface, and stackable objects. For my stackable objects, I used books to hold the two ends of the tape together. And then for formulas, for the relevant ones, we use the Coulomb's law, which calculates the force of the electricity, which is basically the K times Q1 Q times Q2 divided by R, and then the electric field formula, which represents the amount of charge, which is the electric field of the charged particle. The relationship between electric force and the electric field is that the force in the electric field is multiplied by the charge receiving the force, and that the gravitational force is the force of the gravity, which is mass times gravitational constant. For this lab, some relevant assumptions were that we can ignore air resistance, and then that both tapes were addressed as point charges with the same charge magnitude. The charges were evenly distributed, and then the tapes had the same dimension as each other. The sagging piece of tape was levitated by the electric force on the tape. And then for how we performed the experiment, I created a charged piece of tape by attaching a piece of tape on top of another piece of tape and ripping it off the other piece of tape on a flat surface. And then I created a charged piece of tape to suspend between the two blocks and let it sag. And then I brought the original charged tape underneath the other tape and measured the distance between the two tapes. So with those steps stated, we collected our data with the length and the width of the tape that were set at 20 centimeters and 2 centimeters, respectively. The charge of the tape was positive because we took a negatively charged plastic eraser that I rubbed on my clothes, and it was the tape was attracted to the eraser, which meant that the table is positive, and the separation between the two charged tapes was 0.055 meters. And then I calculated the area of the atom by using the formula, and then my work is on the next slide, and then I calculated the number of atoms as well. With this information, we were able to calculate the force of gravity, the force of electricity on the charge of the tape, and the number of deficient electrons at the total tape. The atoms was the force of the gravity calculated using the force of gravity formula, and because in the force of electricity was basically the same as the force of gravity, but pointing in the opposite direction because it was at equilibrium and it was floating. So the charge of the tape was calculated using the electricity, the force of using Coulomb's law, assuming is what we assumed in the assumptions, and then we assumed that the charges were the same, and we were able to calculate Q, and with Q we were able to find a number of electrons by dividing it by the charge of an electron. And then we were able to get the total tape atoms by calculating the area of the atoms and dividing it by the area of an atom. Here I have my VPython model and GlowScript, which basically did the exact same stuff as mentioned before, but in code, where we define the values in the code, and then we define the tape A and B as point particles as a sphere, and as I stated before, we represented the forces of electricity and force of gravity as arrows. Here we can see that the two forces were drawn on separate ends, which means that they were able to cancel each other out. The system was the upper suspended tape, and then the surrounding was the lower held tape. Some final observations were that the positive charge on the tape indicated that the process of ripping the tape off the other removed electrons, and that the equilibrium point where it was held was able to levitate the suspended tape, showing the electric force balances out the gravitational force acting on the tape. Some sources of error could have been that the tape may have accidentally been touched more than necessary, and that the suspension was difficult to measure accurately and may not have resulted in the most accurate results. For our what if question, I answered it by saying if the roles were switched, the tapes would behave the same way because similar materials behave the same way. The tapes would have been opposite charges and still repel each other, and protons are known to be heavier than electrons, so the movement may not affect. For my why is it important? It's because electrons from the charged tapes will run into your hands since we are conductors. So if we touch the tape, they lose their charge.